Hi, in this new episode of this series, Understanding Rolling Motion, we are going to solve some problems and we are going to apply the concepts and strategies that we have learned till now. So here's the first problem in front of us. And it is given that there is a disc and which is kept on a plank, and the disc is purely rolling as it's given in the problem, right? And angular speed of the disc is given, and the translational speed of the plank is given. And the question is that what is the speed of the center of mass of this disc? What is the velocity of center of mass of this disc, right? Okay, so first of all, I'll draw the schematic of this problem here. So this is the plank, and this is the disc here, which is given, which is purely rolling over plank as it is given. So you must note down that this information we already have, that the disc is purely rolling. And the first inference that you will directly get is that disc is not slipping, right? So there is one thing, one information you already have, all right? So this is the angular speed of the disc, and this is given here as 3v. And we have to find that what is the velocity of center of mass. So this velocity of center of mass I'm calling as VCM, and this question is what is the velocity of center of mass. Alright, so how do we solve this? So first of all, as I told you, what we are going to do is that break the motion of, because this disc is purely rolling and this is only translating. The plank is only translating. So we are going to break the motion of this disc into two parts. So here I'm going to do this. So this disc is, of course, let's say center of mass is moving with some velocity VCM. Then this is the translation part, and then this disc is rotating about its center of mass with angular velocity, which is given as omega. The radius of the disc is given as r in the problem, so we'll take this as r. Alright, now we know that this disc is not slipping, or this disc is purely rolling, from where we get that this is not slipping. So what does that mean? It means that the velocity of this point and velocity of this point of the plank, velocity of these 2 points are same. Alright, so what variable do we have? How many variables do we have in this problem? So if you go to my video and you see that where I teach the general strategy to solve any problem, I'll recall from that video that whenever we have any problem, we will always count the number of variables that you don't know. So here we don't know the value of VCM, and everything else is given in the problem, right? So we need only one equation to solve that one variable, alright? So what is that one equation? From where we are going to get that one equation? So we are going to get that one equation from this information that the disc is not slipping, and we know that if it is not slipping because it's purely rolling, the velocity of this point of the disc, net velocity, always remember, net velocity of this point of the disc and velocity of this point of the plank. So tell me, if you just look at the plank, so here I'll just again zoom in so that I'll just leave little gap between these 2 points of contact. What is the velocity of this point? The whole plank is going with a speed 3v, right? Velocity 3v here. So what is going to be the velocity of this point? Can it be v? It's not possible. See, every object, they will not, in problem, they will never say it's a rigid body, alright? You understand that we are only, our domain is a rigid body and we are talking about rigid bodies, alright? So this point of the plank also is going to have a speed of what? 3v, right? Nothing else. So we understand that the velocity of this point is 3v. Now we have to find out what is the net velocity of this point. Again, we'll do our break the motion strategy. And tell me, if the velocity of center of mass is VCM, what is going to be the velocity of this point? The velocity of this point is also going to be VCM due to this part. And if this is omega and this is r, what is going to be the velocity of this point? It is going to be omega into r. I'll write clearly, omega into r is the velocity of this point. So what is the net velocity of this point? It's VCM minus omega r. So if I consider this direction to be positive, see, we have two directions and we are dealing with two directions. So if I consider this direction to be positive, then it will be VCM minus omega r. So net velocity of this point is VCM minus omega r, and velocity of this point is 3v. So we know that it's not slipping, so these 2 points must have same velocity. So what I'm going to do is that I'm just going to equate it. So VCM minus omega r is going to be equal to 3v. So VCM is going to be nothing but 3v plus omega r. This is as simple as it is, right? So what did we do? We did nothing. We just we had an information. It's not rolling. We used that to write this equation, and just we got the answer. Now let's look at the next problem that is there in front of us. Whoa, this looks a complicated problem now. There's a disc and there are 2 planks. looks scary to me, but if we understand the fundamentals, it's not going to be scary anymore for us. So now again, this plank is going with a speed 2v, and this plank is going with a speed 3v, and we have to find out both. We have to find out the angular speed of disk as well as the translational, because the question is that what is the velocity of its center of mass, which means what is its translational velocity, and what is its angular velocity. Remember, we have two variables to find out here, so we need two equations, so we need two information to write two equations. All right, so I'll again draw the schematic of this problem here. So this is our disk whose radius is given, and this is the plank, and this plank is going with a speed 3v as given in the problem, and this plank is moving with a speed 2v as given in the problem. The radius of the disk is r. Now this is a scary looking problem. Let's imagine, let's assume our two variables. So let's say this is rotating with some angular speed omega, and it is going away, the center of mass is moving with some velocity, let's say vcm again. Alright, now we know that it is, again in the problem, if you notice, it is given that the disk is in pure rolling. So again we understand that if it is in pure rolling, it is not slipping. It is not slipping here, it is not slipping here, right? Again, we have two informations. So see, we can write two equations. So first of all, let's focus at this bottommost point. I zoom in here, I zoom into the whole picture. It is, you know what I do when I zoom in? What I do is that I leave some gap between the points of contact. Actually, they are in contact. So this point, I'm calling this as point 1, I'm calling this as point 2. Or, alright, so, and let's call this as point P, and let's call this as point Q. Alright, you know that this is going with 3V and this is going with 2V. There is some omega that we have assumed, and there is some VCM that we have assumed. And we understand that if omega and VCM we have assumed, we can break the motion of this disk into two parts. That is, one is only VCM, we are forgetting that it is rotating, and the second part is it is only having an angular velocity of omega. Alright, now you see that if it is not slipping here, what the velocity, if this is 3v, what is the velocity of this point? The velocity of this point is 3v as well, right? So this point is going with a velocity 3v. Now what is net velocity of this point? Tell me, net velocity of this point due to this part is VCM, and due to this part is omega r. We have done this so many times, so we will just do this fast. So what is net velocity of this point? The net velocity of this point is, I'm just writing here, it's going to be VCM minus omega r. And we understand that these 2 points, because disk is not slipping, it is in pure rolling, so it is not slipping at both of the points. So this point and this point, they must have what? They must have same velocities. So I'm going to write VCM minus omega r is equal to 3v. This is our first equation. Remember, we have two variables. We don't know omega right now. Omega is not given in the problem, but it's being asked. So now to write our second equation, I'll come to the topmost point. And again, topmost point, this point and this point must have what? They must have same velocities. Why? Because disk is not slipping here as well, right? Alright. So what is the net velocity of this point? If this is going with 2v, at what velocity you think this must be going? This must be going with 2v again. So this is going with a velocity of 2v. So what is the net velocity of the topmost point? So you understand, for topmost point, again due to translation, if this is VCM, what should be this? This should also be VCM, you understand? And if this is omega r, what should be this? This is also going to be omega r. So the net velocity of the topmost point of the disk is going to be VCM plus omega r. So here it is going to be, okay, the diagram has been a little cluttered. So this here I am writing VCM plus omega r. From here you can see VCM plus omega r, both in same direction, so I am adding. And this part is how much? 2v, and these two must have what? Same velocities, because they are not slipping over each other. So second equation is VCM plus omega r is equal to 2v. Now I have two equations and two variables. How to solve? Let's add. Omega r will get cancelled, so we are going to get 2VCM is equal to 5v. So VCM is going to be equal to 5v by 2. So we got the first variable. Now if you put the value of VCM here, you can easily get the value of omega. I'm not going to solve this for you. You can easily solve this yourself. You see that how once we understand the basics, once we understand the fundamental, and we have the general problem solving strategy. What is the general problem solving strategy that we applied here? We applied that, and I'll suggest you that go and watch that video about where I'm talking about how to solve any problem in general. So we have two variables, so we need two equations. That's why we need two informations, and to write those two equations which will solve two variables, and those two informations are coming here. It is not slipping here and not slipping here, and we understand what is the meaning of no slip. Velocity here, velocity here. You see this velocity is same. Similarly, this velocity is same. Using these two informations, we wrote out these two equations, we solved it, we get the answer, as simple as it is.